Welcome back to another edition of Mathematics here with IBSL. Guys, we're going to move on to Unit 9. In Unit 9, we are focusing on both exponential relationships and logarithmic relationships. Know that those two relationships are actually inverses of one another. None of this will be new for you. All review. So it's a good week for Unit 9. There are mostly just sets of problems of stuff you've experienced before. So this is a good little review. I'm going to show you this morning the rules for exponents. Go over those quickly, show you a couple examples, and we'll be good with this first part of lesson 9.1. So in exponents, we have 1, 2, 3, 4, 5 main rules that we'll focus on. The multiplication rule is basically just telling us that if we have a common base b raised to an exponent m, and it's being multiplied by that same common base b, different exponent, we just add those exponents. Again, nothing new. Very simple, straightforward. Our division rule is the opposite of that. So if we have b to the m and it's being divided by a common base b to the n, we subtract those exponents. Simple, straightforward, nothing new. And of course, the zero power rule, which is just telling us that anything to the zero power will automatically be 1. And that actually sets up, I don't know if you've ever seen this before, but that sets up why the negative exponent rule works, so to speak. And so what I mean by that, no, disregard that, strike that. Actually, it can be determined and proven using the division rule. So anyway, let's move on. When you have a negative exponent, that rule states this: if we have a base number to a negative, we can simply invert that, and it becomes as such. So the more general form of that is if we have b to the negative m, that is the same thing as 1 over b to the m. All right. There are those first 4 rules. Our last rule involves what's called power of a power, and that's saying if we have a base value being raised to the power of n to the m, that results in b to the n times m. All right, so there is a slam dunk, fast forward version of those 5 rules. All of those 5 rules lead us to being able to simplify lots of different types of expressions. Let's just take a couple of these. Let's jump over and do B and C from example 1. B and C from example 1, both of those are a nice combination of most of these. So how that works. So this is example 1B. It goes 12. What do we have? A to the 7th, C squared. And this is all over 2a to the 3rd. And what do we have? C to the, I believe that's to the 5th power. And so then how do we go about this? Well, obviously 12 and 2 is simplified to become 6. We're going to subtract 7 and 3, that common base of A, and then C, we're going to subtract that common base of C. And then they want us to make sure that we write these so that we don't necessarily have negative exponents in the end. You're going to get a negative exponent here with this base of C. And so the final way of simplifying that would be 6a to the 4th all over C cubed. Okay, Nothing really. You've seen all of this stuff. Very straightforward. Nothing new. All right, let's do a power of power. This one's a little more interesting. And this is example 1C. And it is taking -4. This is C. It's taking -4 PQ squared and raising it to a power of 3. And what does that mean? The number also gets raised to the power of 3. That's one that often gets forgotten for students, is they just leave it as -4. But when you're all inside the parentheses, there's getting raised to a power of 3, even the numbers. So that would become P to the 1 times 3 times Q to the 2 times 3. So that simplifies to this -64 P cubed Q to the 6th. Simple, straightforward. We'll move on to the next part of 9-1 here in the next video. Have fun with those sets of problems there. Simple, quick, straightforward. See you in the next video.